Hi, this is Garrett Dory, and in this video, I'm going to show you an interesting fix that I had to do to this lighting system I created. So to briefly explain what this system does and how it works, it uses 4 different motion detectors placed around my area to automate the lights in the basement that I'm currently living in. The brains of the operation consist of 3 different control modules placed around the area. Each module contains an Arduino microcontroller and 2 relay boards. And of course, everything is connected, so each of these modules are in constant communication with each other with some wires that run under the floor and up the walls. This module sits behind my couch and it's the host. It initiates communication with and manages the other 2 control modules, and it makes all the decisions about which state the system needs to be in. Each of these blue boxes on the control modules are relays. Each one is used as a switch to turn certain parts of the lighting system on and off. So on this host, one relay is used to switch the entire lighting circuit in the main room, and the other is used to switch these plant lights over here, which are controlled separately. This module hides behind the curtain by the hallway. Its job, with its oh-so-mysterious little red flashing LED, is to take input from 3 of the different motion detectors and report their states back to the host. It then receives a signal from the host to control these 2 relays. One relay is used for switching the hallway lights, and the other is used to switch these little auxiliary lights I have above this beaded curtain. This little guy back here in my bedroom has a pretty important job too. It takes input from this motion detector, sends it to the host, and it too receives information from the host to control these 2 relays. One relay is used to switch the whole lighting circuit in the bedroom, and the other is used to switch the auxiliary lights that I have in the bedroom. So all of this basically just automatically controls all of the lighting in my room so that I never have to touch a single switch to turn on my 20-something different lights. Instant gratification is just so amazing. The light follows me everywhere I go. But anyway, I'm here to talk about a correction that I had to make to this lighting system during the building process because a really interesting little glitch came up and I would just love to share it with you. So there's this little switch here next to the couch with 3 buttons. They are used to manually put the lighting system into different states. I'm not going to go into too much detail here, but just know that pressing different buttons makes the lights do different things. These push buttons are connected to the host with a 2-wire cable. So here's the circuit for that switch. This resistor ladder over here is contained in the switch box next to the couch, and it connects in series with the resistor over here in the host. This forms a voltage divider circuit whose center tap voltage will vary depending on which button or combination of buttons is being pressed. This change in voltage is fed to an analog pin on the microcontroller so that it can determine which button is being pressed. Now I had a problem with this initially because the resistors I used had way too high of a value. I can't remember exactly what values of resistors I was using, but it was somewhere in the tens of kilo ohms range. This allowed very small changes in current along the wire to make its way into the input pin of the microcontroller. As you can see, this control wire is also running parallel with numerous AC line cords, which introduces a lot of electrical interference into this circuit. Because of this, it wasn't always registering the correct button when I pressed one of them, so to fix it, I decided that I needed to use different resistors with a lower value to make the circuit more stable and less susceptible to electrical noise. So I just snipped this little cord here, and then I ripped this switch off of the cabinet, and I slapped it down on the bench and cut off these old resistors. Then I threw some new resistors at it, attached a little cable, and hot glued everything back in place. Then I tied all its wires together, so now all that's left to do is to replace the pull-down resistor in the host, and recalibrate the chunk of programming that's responsible for reading the output of the buttons. Alright, so I'm over here at the host device now, and I'm about ready to replace this resistor. So I'm just going to grab my needle nose pliers and gently pull it out. Oh, what's this? What's going on here? Well shit, the whole lighting system seems to be having a little seizure. Damn, what are we going to do about this? Well, first let's understand why this happens. When I took this resistor out, I made it so that the input pin is floating. That means the pin wasn't attached to anything except for a long wire that just leads to an open circuit in the push buttons next to the couch. Now the impedance of the input pins is extremely high, meaning that even the tiniest amount of current moving through the pin will influence the value that it returns. So you have an open pin connected to nothing other than this long wire that's, in this case, acting like a big antenna and picking up on all sorts of random electrical interference. This causes the value from the analog read function to go crazy, therefore making the microcontroller think the buttons are being pressed sporadically. So what's the solution for this? Well, it's actually pretty simple. Boom, consciousness no more. We just have to go lights out for a couple of minutes so that we can safely work on this control module without it flipping out. So with the power removed, I'm going to put this new pull-down resistor in here, and then I'm going to write some code to print out the analog read value from the pin so that I can record each button's voltage level and reprogram the microcontroller to recognize which button is being pressed. After a little bit of tweaking, all of the buttons are now doing exactly what they're supposed to do, and the lighting system is pretty much working just how it should. So always remember to cut off the power to your circuit before you work on it to avoid short circuits and other unexpected problems that could come up. And that's about it for this video, so thank you for watching. Hope you enjoyed. Bye.